everybody. Thank you for coming. I know getting back into the conference mood, it has been difficult these last couple of weeks, but you've made it, so welcome. Today, we will be looking into the multiplayer fundamentals and specifically what the different questions are that you have to ask yourself before you even decide to develop your product to know whether or not that is even within your interest. I'm Timothee Engel, producer and software engineer at Photon. We are a company that develops SDKs and infrastructure for multiplayer games worldwide. And, well, as you can see, we've been around for quite a while, about 20 years at this stage, and cater to studios and industries of all sizes all across the globe. So, we will start with one very, very simple question today. Single player or multiplayer? This question is something I do get a lot as to why or should I even add multiplayer, and that is frankly the wrong question. We are right now at a turning point in game development similar to where website development was about 10 years ago. It is no longer a question of either or, but it's a question of both. Now, this is particularly true not only because players want that and the why we will be looking into in a moment, but it is also true because the technology we have available to us as developers nowadays allows us to, from the get-go, develop one code base, one type of gameplay designing with the restrictions of multiplayer in mind and use that very same framework to then run the game in single-player mode offline. Therefore, the first question is, what are games, or multiplayer games in particular, today? So, there is, as always, in game development and in all creative industries, two sides to the coin. One is, for us creators and devs, okay, we want to just make the best experience, and in this case, an experience that people can share together. But we cannot, by any means, forget that we can only do our job if we have the finances to do so. So, anything from user acquisitions to financing and marketing needs to be taken into account. Now, for the players, it's very straightforward. It is simple fun. It is gameplay. It is what they do in their pastime. It is essentially entertainment. Now, as with any entertainment product, we compete in a market for people's attention span. And it is therefore important to understand why people do actually want to play games that are either multiplayer or that will make them more interesting to your player base. In 2021, the Agency for Video Game Research in France has done extensive questionnaires, and I will translate quickly for the non-French speaker among you. That is, the people that play multiplayer, there's a growing percentage, almost 40 at this point, so over almost half, that does want to play games that are online. Now, the reason for that is very, very simple, and that is because they want to be part of their community. Keep in mind that as human beings, we are first and foremost social animals. It is the reason why over the last centuries we have evolved into societies. We need human contact, despite what we have experienced over the last 2 years, or maybe especially because of that. And this growing trend of wanting to connect with people, not only in analog games like we have had in board games, but now also throughout our digital experiences, such as, well, simply video games, is increasingly important, especially for the new generations that are digital natives. Now, this is also reflected in the state of the market. If we just look at the top grossing mobile games, and in this case here also top grossing games across all other platforms, all of them, to some extent, have had a multiplayer feature. All the ones that are checked completely have real-time multiplayer, and the couple that have a half-check mod, such as Coinmaster have asynchronous multiplayer features to at least that can be extended to things like leaderboards or friend requests and these kind of things where people share their experience but just not at the very same time. Obviously, multiplayer is not only about the experience but also for us as devs very important to take into consideration when it comes to the actual development of the game. Or if you prefer, the life cycle that we have of the game. In particular, if you look at it from a studio management perspective, why would you want to change the life cycle model that you currently have if you're just doing release of single-player games? Well, as per usual, the answer is very simple, cash flow. Currently, if we just work on single-player experiences, most of them only have a return on investment once it's released, which means you have to hopefully have earned enough money to, well, go through the full release period of your first game and then hope that the sales of the next one will recover everything that you have already spent and what you will need for your next development cycle. This is, of course, not only needed for the development of the project itself, but just running your studio in general. Otherwise, how are you going to operate? Now, when it comes to the development part, which is what we're here for today, this is what it would typically look like for a multiplayer game. You have more iterative development, and especially because it is more iterative, you can get it out more quickly if your game type and your gameplay that you have designed fits into that structure. Now, if we go back to the question of when will your cash flow actually start running again for such a project, it is here. If your gameplay and your game is such that it can be played by players as soon as it hits, for instance, an alpha stage or early access on Steam, you will already see an influx of income at that very first release. Now, in addition to that, there is one very important part to take into consideration, and that is player feedback. Because after all, it doesn't matter whether we build a game that is just for ourselves. If we do this as a business, we have to make sure that, that either we have something that is attractive to the players or that we better understand what they want from us so that we can adjust to better cater to the player base that we're targeting. Which means, once we have hit that first release, we will be basically in a dual relationship where on one hand we can keep iterating based on what we have gathered in terms of data for the actual game design and of course then the live operation of the game. Now this particular part is then of course important because it will decide how you ship your updates, how you decide to monetize your content, and especially with the growing understanding that predatory business models are definitely not sustainable, it helps to understand it from the get-go so you can decide what is suitable for your game, for your players, and also for you as a business to say, okay, that is what we stand behind, that's what we are offering, and this is how we're going to finance it in the long term. Of course, this is then seen in everything from how you decide your business strategy, your user acquisition, and your marketing, which then will come back to what you earn. But enough about the business side. If you go into multiplayer, what are the different things that you have to take into consideration from a technological side? Now, this is of course just an example of what we offer, but this is completely transferable to any other type of technology, and that is the different layers of your game. The first one is the infrastructure that you have to have in order to simply synchronize the data, send it, and just generally keep players connected to one another in real time. The other part, of course, as we mentioned, is because it is a social aspect, a social game. You need to know how a player is actually going to exchange with one another in terms of, well, either voice or text. And finally, and that is probably the very most important part, is your gameplay. How is your gameplay going to be synchronized and communicated in real time across all the devices? Well, there are two choices, and these choices haven't changed in about 30 years at this point. You have state transfer, which is the classical one, and determinism. I will go more into detail into what these technologies are, and more importantly, how you decide which one is fitting for the type of game that you're building. But first of all, let's clarify something here, because although these terms are used a lot, they're not as meaningful as what they actually represent. And that is state synchronization, so synchronizing the actual state of your game across all the machines, or just synchronizing the inputs of your players between the different machines for the simulation. We will first look into the state transfer synchronization because that is the most commonplace. So, the tech has been around since the late 90s, and it really is still based on the same concept of transferring that very state of the game to all the players. That is, of course, meant for a certain type of game, specifically those either with high player counts or very fast-paced games with low player counts. Now, what exactly happens is that the game state itself is being sent from whatever the server is to your different clients, or so the different players. And in these games, you again have two different types. You, for instance, have the A-team deathmatch, such as your Counter-Strikes, or you have smaller MMO instances that go usually around 160, 200, 250 players at the most. This is all dependent on how often you need to update that game state from the server to the clients, or in other words, the tick rate. Now, the bandwidth is probably the most misunderstood part of that equation, because although we do consider all home computers having a good bandwidth, what has happened over the last 20 years is that the consumer bandwidth has been optimized for downstream content. In other words, things such as watching Netflix, getting your data for downloading a file, or anything else that requires you to, as a consumer, get information from the internet, as a vague thing if you want, down to your computer. What it has not been optimized for is upstream, meaning what you send from your computer to the world into the internet. This is the very reason why, even in the early 2000s, you could still run pretty bandwidth-intensive games on just a business connection, because business connections that you have at the office, contrary to the ones that you have at home, are optimized for upstream, which means you have all the multiplayer games, especially at the beginning, who could run off a one desktop computer in somebody's office. But back to state transfer. What does it actually do? Well, it simply sends snapshots of the actual state of your game, so where is somebody located, what objects are alive or not, what has currently happened, compresses that data down, and then is being sent to each and every player, where it is then uncompressed and then applied to the actual objects that exist locally, so overwriting whatever might have existed before. Of course, you might think, why do we need to send all of the data? Well, you don't. If you have a very big game, especially if you go into everything that is Battle Royale, or if you scale up something like Minecraft, you don't, because there's going to be a lot of data in the world that players don't care or don't see from their location. This is what areas of interest are used for. It is essentially checking, okay, what data is relevant to a certain player, and is just sending that particular data to them. Everything else is essentially ignored as far as this player is concerned. This helps two things. One, of course, having bigger worlds because your game state is too big, or also cheating to a certain extent because players don't have all the information about everything happening in the game. Then again, it also helps the actual bandwidth, because the snapshots even if you just compress them to only the changes that have existed, are linear. That means the bigger and the more objects you have in your game, the more players you have, the more bandwidth it will require. And bandwidth is expensive. If you use eventual consistency, which relies on the area of interest, it allows you to say, okay, we just assume that the server knows everything, and every other player will eventually know what they need to know when they need to know it. This is a lot more relative, but works just as well. Again, for different types of games, usually slower-paced ones. Which brings us then to the final aspect of that technology, which is what we call topologies, or if you prefer, the way that the infrastructure is set up. The most common that you will have heard of is dedicated servers, where your whole simulation runs on a machine somewhere else, connected usually to a data center, and then streamed down to the clients. This is very good if you need various things. First of all, you know that the authority of your game, the only person that basically will be able to say, okay, this is correct or this is false, is your dedicated server. You will also know that any player that connects will be able to get the state from that particular server at any point in time, regardless of when they have joined the game. And finally, of course, the quality of service. It's the stability of the game engine itself. It is a practice that has been around for decades and therefore very stable. The bigger downside is, of course, the included cost, because just as bandwidth, CPU time is very costly. Therefore, there is another option that is quite commonplace nowadays, and that is the host, or rather the client server, as some call it, where simply one of the players is actually also hosting one server instance that simulates the game. Now, this has pros and cons, as everything does. First of all, when it comes again to who has the last say about what has actually happened, you don't have that full trustworthiness of the server anymore, because it runs on a machine that you do not control. And that is unfortunately a downside there is no getting around to if you decide to go this way. The other aspect is, of course, host migration. This is something that will very much depend on your own implementation or also on the infrastructure you use. Host migration is basically the concept wherein if this player that hosts a game drops out, stops the game, the connection cuts out, whatever, who will be then chosen to host the game without it being interrupted, or at the very least, not interrupted too long to impact the player experience. Then again, there is the aspect of latency. And as I mentioned previously, the bandwidth that is offered to consumers is not meant for upload, which means when you're running a game that might have a big game state and you have 10, 20, 30 players connected to them, the amount of data that they have to upload per second will be possibly higher than they can provide. And in these instances, it's exactly where the player experience will be very variant depending on who is being able to host the game. If you connect to somebody who hosts it in Australia, for you as playing in Sweden, it will be a very different experience than somebody hosting it, let's say, in Denmark or in Germany. But there is also a massive plus, which is cost. This is probably the most cost-efficient way to handle it if you decide to go for a server-client architecture. And then finally, we have what we call shared authority, or client authority, as it's also known by, wherein essentially the server is not the one who will be deciding, yes, you're correct or you're wrong, but every single player will be the last authority on whether or not their action has actually happened or not. This has a lot of pros, with the major con being, again, that you are not sure whether or not you can trust it. In this instance, you would have probably to install something in your infrastructure itself that verifies the actions of the players and what they have validated themselves. This can take many forms, but all of them will increase the cost. But, as I mentioned, there is an alternative to state transfer, which is the determinism, or input synchronization. Now, this is one of probably the ones that has existed almost as long as state transfer. However, it is one that is very misunderstood and not used as much in games for the simple reason that there are not that many commercial products actually using determinism. But first of all, what is it? Well, determinism is a philosophical concept wherein you can predict any given event in the future if you were able to know the current state of all the particles in existence. This is, of course, in reality something that we cannot achieve because, well, there's simply too many molecules and we don't have computers or anything else powerful enough to not only contain the data but also process it in a meaningful way within our human time span. Now, this is, of course, different in games because the amount of data that we're working with is not only smaller, but we can also define what it means, how it is computed, and what the results should be. That means if we know the game states, we can be sure that it's going to be the same everywhere, all the time, by synchronizing the only thing we as game developers cannot control, which is player input. The advantage here is that as far as your gameplay is concerned, as far as your simulation is concerned, and, well, at the end of the day, your gameplay programs are concerned, everything is just one simulation, just like when you do a local multiplayer game. The only thing that matters is input, which the simulation pulls and receives from the server so that you, as a developer, don't have to care about it. It's just getting fed into it. It's the same for everybody. And the simulation, since it is deterministic, will always come up with the same results if it gets the same input from the server. Now, of course, from a networking perspective, it all gets a bit more complicated. Not that, again, you as a developer in a deterministic environment need to care about, but as background, all of the input is, of course, relayed centrally, validated, timestamped, and synchronized across the machines to ensure, again, that the input is consumed in the right order to come to the same effects and causes in the actual simulation. Now, if we look at the tech stack itself, that means that you have your network, which is your infrastructure and your packets. You have your inputs, which can be anything from mouse, keyboard, gamepads, or anything more exotic that you might want, in particular if you're in VR. And then you have your simulation. And this is probably the most important aspect when it comes to determinism, is that anything that touches on your gameplay, every single aspect, whether it is physics, AI, even animation control, if you want to use root motion, has to be fully deterministic. It cannot, at any point, use a value or something that is not guaranteed to give the same result on every platform, on every machine that you're working on. Then you have, of course, another part, the view. So, your effects, your animations, if you're not using them for gameplay, your input possibly because, again, you're just pulling it from an external device. These things work just as usual because, again, they're not relevant to the simulation itself. They're built on top of it. Now, that also means that there's actually only one topology when it comes to determinism. Every player has the same simulation. Every player sends inputs, and every player receives inputs that has been validated and timestamped by the central server. That means you don't have to worry about authority since the simulation on every device has the same authority and will come up with the same results. So you don't have to check anything there. The room, since it keeps track of the inputs, will have the full game state that can be re-simulated for players who join later in the game, so you don't have to create a snapshot of the whole game state. And when it comes to latency, the only person that will be negatively impacted if they have a bad connection is that very single player that has the bad connection, because it will simply time out to the server and not impact anyone else's simulation. This is particularly important if you go on platforms like mobile, where the internet might be unreliable or simply unpredictable. If you're in one house, for instance, using 3G, and you move from one room to another and there's a water pipe in the middle, your connection can drop drastically even though you might have 4G. And then, of course, it is very cost efficient because, as we saw, contrary to state transfer, you do not have to run any server anywhere. Now, of course, that brings us to an important question, which is, what is the actual best technology to make multiplayer games? A question I do receive a lot. And the problem here is that best is a very loaded word, because depending on who might be asking that very question, it could be for producers, okay, what is actually the most affordable solution, or what is going to be able to be used by my team very quickly to transfer their skills? For programmers, it might simply be, okay, what is the most performance, or what is the thing that I can integrate with the existing frameworks the easiest? For designers, it might be, okay, what technology is the one that will represent my vision the most accurately, or easier to use for things like level design? Well, as per usual, the answer is it depends. Because it is actually not a question. It is much simpler than that, because it has two steps. It's like, first of all, it's not about what is the best tech, but rather what is the actual problem that your gameplay represents in a multiplayer context. Is it the amount of players? Is it the pace of your game? Is it the amount of information? Is it the physics simulation? And once you have identified what your problem is, you can then decide, okay, this is the best solution, this is the best technology that actually addresses the problem that I'm having. At the end of the day, all technologies try to solve one particular aspect of multiplayer games. They cannot solve all of them simultaneously. This is simply not possible. Therefore, the answer is, if you want a single one, well, it's in the gameplay. And as we have seen throughout this, the aspects of your gameplay that you have to decide is, first of all, what kind of game is it? So, is it a shooter? Is it an RTS? Is it a fighting game? Is it a mobile game? Is it casual? Is it social engineering? How big is the game? So what is the game state size? Like, how much information do I need to actually carry between every single client? How many players are there to begin with? And then there are other things that are related to your infrastructure. What kind of platforms are you running it on? Are you running on Switch, on Xbox, on PC, on mobile? Are you expecting people to be at home, at work, on the commute? Of course, the ever-present question of cost is as well. Are you a big studio, a small studio? Do you plan on having aggressive monetization, a premium model, something in between? And also, finally, authority. Who has the say? Is it a casual game where you don't care about cheating? Is it a competitive game where every single second counts and it has to be fair for all players, so you need a centralized infrastructure that people connect to rather than a player hosting the game? These are the questions that you have to ask yourself when looking at identifying the actual problem. Now, as I previously mentioned, we've been in the business for 20 years. We have seen a lot of multiplayer games, we have seen a lot of technologies, and we have developed a lot of sales. So we have attempted, at the very least, to simplify the different game types, at least the most known ones, in 4 different quadrants. These represent the 4 topologies that we have looked at. So determinism, shared authority, client host, and dedicated server. Based on your game type, there's a good chance that these are the best solutions for a given problem. If you're doing an RTS game, such as your Age of Empires, for instance, the amount of units that you have on your screen and in your game at any given time is simply too massive to properly transfer it over the internet without worrying about packet loss. And in this case, you definitely do want to go with a deterministic infrastructure. On the other hand, if you're going to do a competitive FPS, and it needs to be fair, and it needs to be authoritative, you are going to go with a dedicated server. That is the way it's going to be the most efficient and at least the most fair as well in the eyes of the players. If you're doing something cooperative, like a Borderlands or Left 4 Dead, well, I mean, that is something players do among themselves. There's no competitive element. People just enjoy playing together. So you are able to just go with a client-host infrastructure that is not only cheaper for you, but also just the same code as a dedicated server. Then again, if you go into something like training, like in industries, and you go, okay, the most important is that the user has immediate reactions and there is no point in cheating these simulations, we can give it to the client as its authority and just have a shared model. Now, of course, all of this evolves with your different gameplay specificities, the details, there's simply too many variables to just say, yes, that is the answer. This is the foundation that you can build on and then decide, okay, is it actually my gameplay type? Are you merging different game types and actually need a mixture? That is for you to decide. And after all, we are still here at the Linköping University Game Conference. Therefore, I will leave you also with some reading. If you're interested in everything that is related to multiplayer game programming, as in gameplay, I highly recommend the very first book, Multiplayer Game Programming. It's going to go over most of the concepts that you have to be familiar with if you do this kind of games. If you are more interested in the actual low-level architecturing of multiplayer infrastructure, I highly recommend this book series by No Box Hair. Thank you very much for your attention, and now I hope that I can answer some questions for you.
Thank you.
You're welcome.
How did that feel?
Same as usual.
Because same as usual. No, because we were talking about this book. There's so much you want to talk about this because it's a big question for a lot of people. But even going into multiplayer, what would you say is the biggest, difference between that and single player game?
Multiplayer is a lot less forgiving of mistakes. It's not more difficult, but you have to be familiar with the patterns and paradigms that multiplayer games have to work within. And among other things, the simple fact that the internet is an analog infrastructure. So data cannot be sent faster than the speed of light. Knowing this and knowing that the technologies have solved all of the technical issues, a lot of time will, on your side, have to be spent on understanding what are the design implications for you in terms of wind-up of powers, animations, etc., to design the gameplay that is not only what you want, but also that is fitting for something where data might take a fraction of a second to actually reach your player.
Yeah, so there's a lot of, obviously then there's a lot of things to consider, but I'm assuming that you have this idea in the very beginning that you want to do a multiplayer game because you want to have this sort of cooperation or...
Yes, you would hope so. Like, the only person that can tell you to have multiplayer in your game is yourself. Nobody can convince you to add multiplayer after the fact. Not only because your game might not actually suit a multiplayer game if it hasn't been designed for it, but also because adding multiplayer after you have already developed the game is very costly.
And like you said before, as getting the money back on the game you're developing, then multiplayer is one good way to go.
Yes. I mean, the thing to keep in mind is a multiplayer game is in itself not more expensive to run necessarily, but if you have people connecting over the internet, you incur costs like drinking water or using electricity when these people are online. This is unavoidable. And therefore, you have to have a monetization strategy that allows you to cover the costs. Now, these costs tend to be a fraction of what is estimated, because only the currently connected players is what's important, not how many players are actually playing your game offline or in a given month. So it is a lot easier than expected usually, if you take it into consideration from the get-go.
We have a question as well, which is specific to one part of your talk where you were talking about area of interest.
Yes.
Is that only relevant for server-based games, or can it be used for player-to-player or peer-to-peer games as well?
You can't use it. Well, okay, so it depends what peer-to-peer is meant. It is technically everything, even nowadays, is peer-to-peer. Peer-to-peer only means that you have one machine connecting to another directly, which, whether you have a player connecting to another player or a player connecting to a server, either of those are peer-to-peer. If we're taking peer-to-peer in the classical 90 sense of the word, as in every player is connected to every other player, you cannot use areas of interest because every player needs to get all the information from every other player all the time. So unless you're using a client-server architecture, whether it is as a client host or as a dedicated server, you cannot use area of interest, no.
Well, thank you very much. I think that answered that question. And I'm sure that if you have more questions and they come up to you afterwards.
Oh, yes, I'll be here all day,
well.
so just grab me in the floor tonight at the party.
Yeah, right. Oh, yeah, definitely at the party.